Hi everyone, my name is Lokesh. I am a mechanical engineering student from Osmania University, Hyderabad. As part of the Altair Inspire competition, I will be demonstrating the process of performing of multimotion dynamic analysis and topology optimization for swingarm of e-scooter. So without further let's get started. To begin with, I choose an electric scooter as the base model for my multi-motion dynamic study. My primary goal was to optimize the swing arm to reduce weight while maintaining strength and durability under real-time dynamic conditions. And I selected aluminum as the material, considering its high strength to weight ratio. I removed all the unnecessary parts that are not essential for the multi-motion dynamics. Next, I applied ground constraint and added joints based on the motion and movement of the e-scooter. During this process, I encountered a design issue where I was unable to define a rotational joint. To solve this, I modified the design by adding a hole at the required location to enable free rotation, which allows me to properly define the rotational joint. After setting up the joints and fixing the design issue, I applied a Boolean operation to combine all the relevant parts of swing arm into a single solid component. This was essential to ensure proper behavior during the motion simulation. To ensure the spring is properly connected between the swing arm and frame, I added an extra part. This connector helps maintain a correct alignment and a realistic spring behavior during the motion analysis. I applied a force of 800 newtons on both sides of connected part between the swing arm and the frame. A motor was added with a rotational speed of 60 rpm. To identify and rectify any motion related issue, I performed a motion run analysis. So, how different joints affect the movement and behavior of the swing arm and allowed me to fine tune the setup. I added an actuator to the swing arm with a 30 displacement to generate the required linear motion. After applying all constraints, joints, and forces, I ran the motion analysis. The simulation result showed that the loads on the swing arm were within the allowable limits for aluminum, which confirmed that design safety under operational conditions are safe. By using the Force Explorer tool, we can easily view the maximum force acting on the spring and the torque generated by the motor. I initially tried to perform topology optimization directly on the full swing arm assembly within the motion analysis setup, but it was taking a huge time. To solve this, I isolated the swing arm component and performed a static topology optimization separately. I reapplied the material properties, loads, constraints, actuator force, and the torque to replicate realistic conditions. Here I applied three load cases based on different combinations of forces and supports. Each load case represents a specific condition to accurately simulate the structural behavior of the swing arm under varying scenarios. And now I am running the simulation. for the swingarm to analyze its structural performance under the applied load cases. By comparing multi-motion dynamic analysis for the swingarm and a separate static analysis on the isolated swingarm, I compared the factor of safety and von Mises test values from both methods. The results were quite similar with only minor variations. These differences are expected since the motion simulation was run in fast mode, so instead of accurate to save time. In both cases, the von Mises test remained well below yield strength of aluminium T3, which is 324 megapascal. The factor of safety was also well. After completing the simulation, I proceeded with the topology optimization for the swing arm. Here I noticed a misalignment or a small gap in the optimized geometry. To address this issue, I improved the smoothness and connectivity. I am using a PolyNURBS to refine the shape and ensure a proper connections between the parts. After refining the optimized part, I performed a structural analysis on the modified geometry. The results were then compared with the previous design, and all the stresses values remained within the allowable limit for the material.